Last lesson of Unit 9. It's going by fast. So as we can see, it's a hyperbola. What's a hyperbola? Well, again, watch the pre-lesson. But in a nutshell, a hyperbola is either two parabolas facing opposite directions up and down, or it's two parabolas facing opposite directions right and left. So, as you can see, this here is a hyperbola, this is a parabola, this is a parabola, but they're two parabolas facing opposite directions. I want you to notice something. There's a minus, it still equals 1, but a squared comes first. Look at it. And if x squared comes first or is positive, notice the Pac-Men are having a feast on the x-axis, telling you they face right and left. However, if y squared comes first or is positive, then our Pac-Men are eating all the dots on the y-axis. That's how I teach it. So I think it makes a lot of sense. I think it makes it pretty simple. Now, on this one, starts out, and again, you got to watch the pre-lesson for this to make total sense. Let me move this a little bit. There we go. Okay, so what do? Well, according to the pre-lesson, we just take the square root of that, and we get 6. Because again, notice in this, it's very important you guys understand this, a squared just comes first. If we were dealing with ellipses, remember we said a squared is bigger than b squared? That's not true for hyperbolas, and that is a major, major difference. A squared simply comes first. So I know that a squared equals 36, so if I take the square root of both sides, I get a is 6. And then this is b squared, so b squared equals 16, take the square root, I get b is 4. Now watch this. That means I travel 6 units along the x-axis, 4 units along the y-axis. So let's get the drawing going here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then we go up the y-axis, 1, 2, 3, 4. 1, 2, 3, 4. And if this was an ellipse, that'd be a plus. And then I would just go like this, and I'd be done with drawing the ellipse. But this is a hyperbola. So we have to make the hyperbola box. Not looking for perfection, so don't get too stressed out. Make your diagonals extremely long. And then we got to ask ourselves a question. Are they going to go like this or like this? And I've already given the clue away. Notice x squared is my positive stuff, so it's going to be like this. Now why the box? That dot right there is the vertex of your one parabola, and that dot right there is the vertex of your other parabola. So why is the need for the box? Well, it determines how wide these are or how narrow they are. Now, if you notice up here, well, I could just say it this way. Remember when we talked about parabolas and that was the focus or the pistil, and that's the vertex? This is just the same thing. So the focus has to be in here somewhere and in here somewhere, which means it's going to be on the x-axis, which is huge. So the formula is right here. It looks just like the Pythagorean theorem. So here we go. We're going to go c squared equals a squared, which is 36, plus b squared, which is 16. So c squared equals 52. Take the square root of both sides. Bada boom, bada bing, do the right thing. Because there's going to be 2 of them, it helps to go plus or minus. This breaks down into 4 and 13. I'm not sure if they're going to hold you to that, but I think they will. So it's plus or minus 2 square root of 13. Now, how do I make sure to make a coordinate point and it's on the x-axis? This has to go first. Plus or minus 2 square root of 3, comma 0. And there's my foci, plural. All right. And that's pretty much it. But let's just try another one. Major clue, it has to equal 1. So we're going to have to subtract 25. Subtract 25. Now there's a big trick coming. So I hope I have your attention. So this is going to turn into x squared minus 25y squared equals negative 25. Now, as you can see, just like an ellipse, it has to equal 1 and it has to equal 1 regardless of what they end up looking like. So that's telling me what to do next. I have to divide by negative 25, divide by negative 25, divide by negative 25. Here's where my little clue earlier is going to start making sense. I said positive stuff comes first. Positive stuff comes first. And then we subtract, or the negative stuff comes second. The negative stuff comes second. Because look at, we're going to have to do a little switcheroo. What's a negative divided by a negative? Positive. Where's the positive stuff go? First. So keep that in mind. A little math trickeration right there. So I'm going to take this, simplify it, and I know it's going to be y squared. Now I need a denominator, so that's going to be 1, because that's going to give me the dimensions of my box. And then you see that negative down underneath there? I'm going to take advantage of it and just bring it out and turn it into subtraction. X squared over 25 equals 1. Now I can get rocking and rolling. Again, the size doesn't matter in determining whether it's a squared or b squared. It's whatever's first or positive. So there's my a squared. So I take the square root, and I'm going to travel along the y-axis 1 unit. This is my b squared. So b squared is 25. So b is 5. So I'm going to go 1, 2, 3, 4, 5, put a dot. 1, 2, 3, 4, 5, put a dot. Make my box. Draw these. It's kind of difficult to draw those when the box is so flat, but you guys will get her done. And now I have to ask myself the question, which way is this going to go? Well, because my y squared is my positive, or it's what I start with, it's going to go like this, and it's going to go like this. Very wide Pac-Man. But that's it. Also, foci. A squared plus b squared equals c squared. I just flipped it around. And what's a squared? 1. What's b squared? 25 equals c squared. So 26 equals c squared. Bada boom, bada bing. Again, the foci on this one has to be on my y-axis. How do I show that I know that? Oh, and by the way, it's bada boom, bada bing, do the right thing, because I'm going to have 2 foci, so it's 0 plus or minus the square root of 26. And there it is. Hopefully you guys are getting it. 2 more, and we're done. Now this says, sketch the graph by hand and state the foci. Same stuff. Well, I got to subtract my 9y squared, subtract 9y squared, rewrite it, x squared minus 9y squared equals negative 81. Now just remember something. If this is a negative, that's going to tell you you're going to need a switch roo to make this make sense. And so I divide by negative 81. I get a 1 equals, notice this is going to be a positive, so I'm going to write that first. What's a negative divided by negative? Positive. What is 9/81 reduced to? Y squared over 9. Now, x squared over negative 81, that's going to be my minus x squared over 81. And now it looks proper. This is my a squared because it's positive, or it comes first. So a is 3. So I'm going to travel up my y-axis 3, down my y-axis 3. Remember, because it's underneath my y stuff. Now I'm going to go b squared equals 81. So I get b is 9. So I'm going to go out 9, make my box, draw in my diagonals. These are called asymptotes. You'll learn a lot about those in pre-calculus. Now you make a determination. Which way is this hyperbola going to go? Up and down or right and left? Because it starts with my y stuff, it's going to go up. Whoops, I should have went closer, but and then like this. Last thing I have to do is find the foci. A squared is 9. B squared is 81. So here's my a squared plus my b squared equals c squared. So I get 90 equals c squared. Bada boom, bada bing, do the right thing. We should probably, by habit, break that down. So I get plus or minus 3 square root of 10. Now where does the 0 go? It goes in the front, because this is the only way it guarantees that I know it's going to be on the y-axis if the 0 comes in the front. Because that means if I plot it, I don't go to the left, I don't go to the right, I just go up and down those distances. Okay? Last one. Well, subtract 64, 16y squared minus 4x squared equals negative 64. Again, when this is negative, there's going to be a little switcheroo. And so here we go. Equals 1. Here's my positive stuff, so I'm going to put that first. Here comes the switcheroo. 4 over 64 is 1/16. So it's x squared over 16. Because this is negative, I'm just going to subtract it. 16 over 64 would be 1/4. So I'm going to write it as y squared over 4. And now I'm ready to analyze this. Here's my a squared, not because it's bigger, but because it's first. Here's my b squared. So a is 4, b is 2. I travel along the x-axis. 1, 2, 3, 4. 2, 3, 4. And now b is 2. 1, 2, 1, 2. Make your box. Draw in your diagonals. And then because it starts with my x squared, or my x squared stuff is positive, it's going to go to the right and to the left, because it gobbles up the points on the x-axis. Where's the foci? Well, a squared plus b squared equals c squared. A squared is 16, b squared is 4. So I get 20 equals c squared. Take the square root. Bada boom, bada bing, do the right thing. So that's plus or minus 2 square root of 5, because it's the square root of 4 times the square root of 5. I just didn't show my work. And because it needs to be on my x-axis, it's going to be plus or minus 2 square root of 5, comma, 0. There's my foci. Zip, plural. There you go.